Hey guys, just wanted to do a quick calculation. This is the U-try problem from the centripetal force notes. It also comes from the physics day trip that we'll take in May to Michigan Adventure. I'd like to calculate the forces that a rider experiences and feels at the bottom of the roller coaster. So to do this, before I begin, I'd like to draw a force diagram. So we're talking about down here at the bottom of the ride, and I'm only going to talk about the vertical forces involved. There is two. There is the weight of the rider that acts down, and then there is the bottom of the roller coaster, which pushes up on the rider, which we call the normal force. And I purposefully drew that bigger. Typically we say that the normal force and weight are equal, but we can see that the roller coaster is turning. It was going down and now it's going up, and so the only way for something to turn is if there is an imbalance of forces that's acting on it, equivalent to that centripetal force formula that we have. And so the imbalance must be caused by the normal force. We can write a formula for that. That is, the net force is equal to the normal minus the weight. And what I'm interested in this problem is the normal force. That is the force that the rider feels. So if we add weight to both sides, we get that the normal force is equal to the net force plus weight. And I recall from earlier, the last video, that the net force must be equal to that formula for centripetal force. And so let's write our equation here, and then we can make some substitutions and solve it. So the net force plus weight. In this case, the net force is equal to the centripetal force formula, which is mv squared over r. And the weight is equal to mg. We can factor out the math, and we get a formula, v squared over r plus g times the math. That's equal to the force that the rider experiences. Now, if we start to look at some numbers, this is a mixture of all sorts of different numbers. We have a metric unit of mass, we've got a non-standard English unit of speed, and we have another metric unit of radius. So let's just convert the speed into the metric system. I'll do it quickly. Remember, 1 meter per second is equivalent to 2 miles per hour and 3 feet per second, roughly. So let's just use that approximation and cut the speed in half. We'll say maybe 28 or so meters per second. That will be our v. And so we can start to plug in numbers now. The mass is 50 kilograms. The velocity is 28, and that's squared. And the radius is 20 meters. A word about the radius. That would be if we look at this path down here and we imagine drawing a full circle. That's what the radius is. So with a picture in Photoshop, you could probably measure how many pixels this is and get a sense for the scale and measure it directly. I just gave you a number to use, approximately 20 meters. So anyways, to finish the calculation, we have to include gravity, and in the metric system, which is our other units as well, that's 9.8. And I'll wait for one of you guys to get this. So, any of you guys working on it with your calculator? Oh, Dan, you got it? Okay. Yep. 2450. That's perfect. 2,450. And the unit for this would be, that's right, newtons. Awesome. So 2450 newtons, that's what a rider experiences at the bottom. And if you were to convert that into pounds. That's dividing by 4.45. Anyone got that one? Oh, Dan, you got it again? Great. Just over 550 pounds. Awesome. So, there's one more example of a calculation involving centripetal force and centripetal accelerations. So, what I'd like you to do for the rest of the class time today is look at, first of all, the rotation worksheet that you've been working on all week. Make sure that you have found your answers in the answer sheet and that you've turned that in to Mr. Hausler. And then you should continue by practicing the supplemental problems that are right after this page in your notes. Please do as many of those as you can, and there is another answer sheet, a small little slip of paper that has the answers in there. Just one quick word about units. In number 48, the unit of force that I measured things in is in dynes, and that was not to trick you. A dyne is the standard unit if you use grams for mass, centimeters per second for speeds, centimeters for distances, seconds for time. It's called the centimeter gram system, and dyne is the natural unit for that. And so that was actually to make 48 very easy. You don't have to do any unit conversions. You can just use the formula and make sure that you're using it correctly and find your answer in dynes. So have a wonderful weekend. I do want you to watch the centripetal acceleration and centripetal force videos if you haven't yet. And I'll also be posting up a video on gravity and on orbits later on. You could probably watch that Monday evening if you wanted to as well. But if you wanted to get ahead, you can watch that sometime as soon as you see it. So again, have a great weekend, and I will see you Monday. Bye.